everyone. Matrix, it is finally your time to shine. Welcome back to Tenfold Live. My name is Philippa and I'm here on this beautiful Tuesday evening to bring you another episode of Matric Maths. This is one of many episodes brought to you by Liberty, so thank you Liberty for sponsoring us. We could not have done it without you. Today we're focusing on analytical geometry. It's the last week of analytical before we go into exam revision. So guys, next week we go through the past papers from last year. We're going to go through every exam paper, try and help you understand what you're going through. If you've already written your exams, I hope you've crushed them. I'm so sure you have. You guys work so hard. If you haven't, make sure you tune in because we're doing some great revision work. For now, we're going to jump right into our analytical geometry episode. So let's check out this intro video just to get us in the zone.
Analytical geometry, also referred to as Cartesian or coordinate geometry. Analytical geometry uses algebraic methods to represent and solve geometry problems. The correspondence between geometric shapes and algebraic equations means we can convert geometric problems into equivalent algebraic problems and solve using algebraic methods. To be successful at analytical geometry, you will need to understand all of the work done up to grade 11 and, in addition, the concepts of equations of circles, equation of a tangent to a circle, and length of a tangent to a circle. In preparation for your exams, make sure to watch all of the analytical geometry videos and attempt all of the assessment equations at the end of the lessons. Once you have mastered those skills, the career video will take you beyond the classroom. Analytical geometry is roughly 40 plus minus 3 marks in the final exam, which is approximately 27% of Maths Paper 2.
Sure guys, when I watch those intro videos, it makes it so obvious to me how many marks that section is in your exam. And analytical geometry is almost a third of your paper. That's a lot of marks, guys. So if you understand your analytical, you're going to crash about a third of your paper. So easy marks, nice diagrams, nice coordinates, nice equations. I'm going to try and help you adjust to all of this stuff and hopefully help you out with your exams. For now, we're going to jump straight into the first question because it's a really long-winded question. And I'm excited to try and get through as much as I can. It's from Avumile. Let's see what he needs help with.
Hello Tenfold, my name is Avumile Matros and I'm from Stokesbraid, studying at Mehlomakulu Senior Secondary School, and I have a problem with this question right here. And here's are the questions.
Alrighty, so guys, you know how we encourage you to send in your question videos every day, every week? Well, if it's that simple to win a prize, why don't you send in your questions? Because Avumile, you have won a 19-inch TV. Courtesy of us, thank you so much for sending in your question. It's that easy, guys. Just show us your question, show us your face, tell us what you're struggling with, and you could win a 19-inch TV and a whole bunch of other great prizes. So congratulations. Let's try and cover your question. Hopefully we can get you to understand. It says, in the diagram below, the straight line AC is drawn, having A and C, Y and X intercepts respectively. Okay, so that's just saying that A is a Y intercept, C is an X intercept. The equation of that line AC is X plus PY is equal to Y, and they make perfect note of the fact that P is greater than 0. P is positive. It is also given that OC is equal to 4 times OA. Okay, so this length here is 4 times this length here. Alrighty. The straight line EB is drawn. So that's this line along here. And B is the point on AC such that EB is perpendicular to AC. Easy peasy. Lastly, it says that EB cuts the y-axis down here at 0 and -7.5, so I'm going to fill that in. And the x-axis at F, which is that point there. So first of all, it says calculate the coordinates of A. Okay, so we made perfect note that A is the y-intercept of that line. Remember that A sits on the line with this equation. Now, I don't like it in that form, so I'm going to put it in standard form. So here if we have x plus py is equal to p, to try and get it into standard form, we try to isolate y. So we say that py is equal to p minus x. And then we divide everything by p. So to write it in standard form, we get y is equal to negative 1 over p being the gradient, multiplied by x, plus p divided by p is 1. Okay, so that's important, guys. That is the equation of this line AC over here. Okay, so we're trying to find A. It says that A was the y-intercept, which means that the x-coordinate at that point is 0. So, easy stuff, guys. We just put x being equal to 0 into this equation, and we get that y is equal to negative 1 over p multiplied by 0 plus 1, which means that the y-coordinate up there is simply 1. So the coordinates of A are 0 and 1. Easy peasy. I'm going to fill that in here to make it easier for me. I also know that the equation of this line here is y is equal to negative 1 over px plus 1. And I remember that this is 0 and negative 7.5. Okay, so the next thing we need to do is calculate the value of p. Okay, so if I look at this diagram here, I see that b lies on that line there that we have the equation of, but when we have a point that has absolutely no coordinate information about it, I look at this diagram and there's no way of me finding B without having some other information. So B is not going to help me in working with this line. So I'm going to still try and work with the line because that's the equation that involves P that we're trying to find. But I'm going to try and look at the intercepts that they've given us because that's kind of sneaky. The moment they say intercept, guys, it means that one of the coordinates is 0. Remember that. Okay, so let's look at this. We already know that A is at 0, 1. We know that C is the x-intercept, which means that C has some or other unknown x value, but its y value is automatically 0. It sits on that x-axis. Okay, so if we make y equal to 0 on this line that it sits on, we get that negative 1 over px plus 1 is equal to 0. Which means that negative 1 over p multiplied by x is equal to negative 1. And then if we divide both sides by negative 1 over p, we get that it'll substitute or divide out on the left-hand side. Negative 1 divided by negative 1 over p, we say times by negative p, which gives us positive p. So at that actual point there, at point C, it means that the x value is equal to the p value. Only at that point, guys. Make sure you understand that. At that x-intercept, the x value at C is equal to that p value. So let's see what else we can work with. Remember, they told us at the beginning, they were very sneaky, and they said that this length here is equal to 4 times this length here. Well, remember that the axes intersect each other at a right angle, which means that this OA is a perfectly vertical length. It goes perfectly up and down, which means that it has no deviation to the sides. That length there, that exact y value of the point A, is that whole distance there. Same along the x-axis with the c value. Because it's a perfectly horizontal length, the c value, or that length there, is equal to the x-coordinate of c. Sneaky stuff. Okay, so here we know that the y value is 1, which means that there is 1 unit. And this here is 4 times that, so this is 4 units, which means that the x value at c is automatically 4. So we have 4 is equal to p. Hopefully that makes sense to you guys. Let's move on. Okay, so remember this line here, we've now found that y is equal to negative 1 over 4x plus 1. A was 0, 1. And E was 0, negative 7.5. C we found was 4, 0. Okay, so Keep on filling in information on your diagram, guys. The moment you find something out that's important to the whole situation, fill it in. Use colors, use highlighters, use little notes down the side. Make sure you annotate your diagram so that you know exactly what you're working with and how what you found in the previous step fits in with other stuff, because that's almost always how geometry works. You find something, the next question is going to use that. Okay, so next question says, determine the equation of EB in the form of y equals mx plus c. EB is this line here. Okay, so usually you would try and find firstly the gradient, and secondly you would either substitute a point in using that gradient to find the equation, or you use the intercept to fill in that last c value, because remember, this c value here is the y-intercept. Remember from your grade 9 function stuff. Okay, so if I look at this here, EB, because we don't have point B, guys, we're trying to find point B. We'll try to find point B at another stage. But because we have EB and we don't have a second point, trying to find the gradient by using change in y over change in x isn't really a logical thing to do, because you're going to have two different unknowns that you have to solve for. That's going to mean simultaneous equations, and then stuff gets ugly. So try and remember what they told you in that love letter at the beginning of the question. Here, it is very important to note, we have a 90 degrees. What does that immediately scream to you? Means that the gradients, guys, remember, gradient of AB, which is this line here, multiplied by the gradient of EB, which is the line we're trying to find the equation of, is equal to -1 because of perpendicular lines. Okay, so the gradient of AB, we can easily see from this equation, is -1 over 4. So we have -1 over 4 multiplied the gradient of EB we're trying to find is equal to -1. If we divide both sides by -1 over 4, we get that the gradient of EB is equal to -1 tipping times -4. Okay, so that means that the gradient of EB is equal to just 4. And that makes sense, guys, because as the x value increases on this EB line, so does the y value. So it's a positive big gradient. But we are not done yet. So we found the gradient here. Now we need to either use a point or the intercept. Okay, so if we look at EB, we have the y-intercept. It sits at E, guys. The y-intercept of line EB sits at point E. And point E has the coordinates 0 and -7.5. Okay, so easy peasy stuff. We have y is equal to, we just found the gradient of 4x minus 7.5, because remember, if you substitute x equals 0 into there, you get the y-intercept of -7.5. So, simple stuff, guys. I know that there are probably a lot more questions that could be based on this kind of question, but for now, that's just great revision of your straight lines, your relationships between perpendicular and parallel lines. Just try to make sense of what they're telling you. If they say something's perpendicular, see if you can use Pythagoras. See if you can use perpendicular gradients. Just try and make note of everything they tell you, guys. Everything is important in that little love letter at the beginning. That's the first question for today's show. Hopefully you guys are in the zone. Your brain's sitting there all nice and happy in its little geometric zone. And we're going to go into an ad break so that your brain can chill a little bit in that zone. And I'll be back with another question afterwards, so stay tuned.